We're going to go through the hypothesis testing for a related samples t-test. Now, as you can see up above here, we have a data set and our alternative hypothesis. So you believe students' energy levels are lower after eating lunch and want to test using alpha 0.05. So that provides us not only basically our H of 1, so give me a second here. So our H of 1, it also provides us our alpha level, which is 0.05, as you can see, 0.05 there highlighted. So I won't rewrite the alternative hypothesis. We're just going to start with going through the steps. Step 1 being stating the hypotheses, and from this point on, I'm just having you state the alternative hypothesis, which is the prediction. So basically, this statement that you can see here, you believe students' energy levels are lower after eating lunch and want to test using alpha 0.05. Actually, just you believe students' energy levels are lower after eating lunch is just enough. Now, we have the alpha 0.05 is our criteria. So in that step 2, we're going to set our criteria. So alpha equals 0.05. Now, this is going to be a one-tell test because you're specifically stating here, let me go to my highlighter, that the energy levels are going to be lower. So that is a one-tell test. So we're going to be looking for our critical value in the left-hand side because lower is suggesting scores will decrease. So we have, bear with me. Just one second. I don't need the highlighter. I need my actual pen. Okay. Our critical value. Now, we're going to be using a different type of degrees of freedom. Yes, we have 2 different data sets before lunch and after lunch, but these are on the same people. So what we're doing is we're testing the energy levels before eating lunch and then after eating lunch. So it's the same exact people. So what we're just doing is basically counting how many participants there are instead of each observation separately. So in this case, 1, 2, 3, 4, 5 people participated, and they were recorded at 2 different occasions. But we're still looking at our sample size of being 5. Now we go back to our typical like single sample type of degrees of freedom, and we're just going to subtract 1 from that. I'm going to put a comma here. We're using degrees of freedom equals 4 because we only have 1 set of participants. Even though they were tested at 2 different times, you can't count people twice, so we're not subtracting 1 from each. So our degrees of freedom equals 4. And we're going to look in our t-distribution table under degrees of 4, looking at 0.05 and 1 tell. So if you look at 0.05, 1 tell, degrees of freedom of 4, you should get a critical value of 2.132. So now we need to make sure we have that as a negative, 2.132. Okay? So if we look, here's our distribution. Okay? We're only putting in this corner, 2.132. Okay? And this is where things are going to be significant, is anywhere over there if our t-test falls in that direction. So now let's go through and start getting our calculations that we need. So I'm going to go to the next page. So here is my actual boundary. Now remember, right down the middle is 0. Okay, so let's look back again. Have to reach 2.13. We're actually right about here. So we're actually at negative 1.21, which is not significant. So now we know that we're retaining the null. We do not have significance. So we are able to actually write our results. Okay? So let's go. So we have our data set. Is what we need to do is start getting our differences. So when we get our differences, those are D. Now, to get our differences, we're basically going to do x2 minus x1, or the x after minus x before. So we're going to subtract our before from our after. So when you look at this, you have to be really careful. So I'm going to put my pen just a little bit thinner. So when I look at this, first participant, before lunch their energy was at 6, after lunch it was 3. So if I do 6 minus 3, if I was going to just go from left to right, it would be 3, positive 3. But in actuality, that person's score went down by 3 points. So it would be a negative 3. Then the second person, their score went down by 3 points. The third person, their score actually went up by 2, so that's a positive 2. The fourth person, theirs went down by 1. And the last person, theirs went down by 2. Okay? So we want to be really careful that we're paying close attention to those signs. We want to make sure that we're not, I'm going to erase this, that we're not going in the wrong direction, because we automatically, as humans, we want to go left to right. But in actuality, we want, in this case, to show whether scores are going up or scores are going down. And in this case, the majority are going down except for 1. Now, once I get the differences, I can basically just ignore this data set and just work with my differences. So at this point, I'll need my sum of D. I will need my mean of the differences. I will need my sum of the differences squared. Okay? And then I'll need my sums of squared of the differences. Okay? So these are the primary things that I'm going to need immediately just to be able to work through this. So to get my sum of D, be very careful with your signs. So it's negative 3 plus negative 3 plus positive 2 plus negative 1 plus negative 1. So there's an actual negative sign on my calculator, and it is right next to my enter button. If you have like a T183, you should have that, and you can just keep it consistent. Otherwise, it's just, minus 3, minus 3. You have to be very careful about your signs. So once you hit enter, your sum of D should be negative 6. Okay? Now, our mean of the differences is just, you're going to take that sum of the difference and divide by how many differences there are. So there's 5. So negative 6 divided by 5 is negative 1.2. So that's just saying the average energy levels went down by 1.2 is what that's saying. Now we need to get the sum of the differences squared. This is where you want to be really careful, because in most of our calculators, it's going to hold the negative signs. So is what I do whenever I'm squaring a number, if it's negative, I just drop that negative. So I'm putting this into my calculator automatically, just 3 squared plus 3 squared plus 2 squared plus 1 squared plus 2 squared equals, so our sum of the differences squared is 27. Now, to get our sums of squared of the differences, if you recall, sums of squared of the differences, it's the sum of d squared minus sum of d total squared divided by n. And I'll put a little d here because the n is how many differences are there. So at this point we can just literally plug and chug. This 27 goes in the first spot minus our -6, so -6 squared. Now again, a negative squared should be a positive, so you have to be careful with that. So then we're dividing that by 5 because we have 5 different scores. So the way I put that in my calculator is 27 minus, and I put a parenthesis, and I'm dropping the negative so that I don't have to worry about if I'm putting my parentheses right, because a -6 squared is a positive number. So then I put parenthesis 6 squared divided by 5, and I close my parenthesis and hit enter. So I end up with 19.8. And I'll put that up here, 19.8. Okay? So I'm going to go ahead and erase this because we've got our sums of squares of the differences. We're going to use that to get our standard deviation. Okay, so our standard deviation of the differences, if you remember, standard deviation equals sums of square over degrees of freedom. I'll take the square root. So basically, we're putting 19.8 divided by 4 because we have 5 different scores. We're going to take the square root. So 19.8 divided by 4 is 4.95. Then we take the square root of that. And we should have, I've got 2.224, and I'm going to round to 9, just to keep this as accurate as possible. Okay, so now we have our standard deviation. I'm going to erase this. Okay, ultimately, we're wanting to get our t obtained, right? So our t obtained for a related measures t-test is the mean of the differences minus our population mean of the differences based on the null, which would be 0, divided by the estimated standard error of the mean differences. Okay? So the estimated standard error is calculated the same way as before. We're just using the differences. So the estimated standard error of the difference is our standard deviation of the differences divided by the square root of n. So we're going to take that 2.2249 divided by the square root of 5. Okay, don't use the degrees of freedom, it should be the sample size. Okay, so 2.2249 divided by the square root of 5 is 0.99499, I'm going to say. Okay? So we have everything we need to calculate our t obtained now. So I'm going to go ahead and plug that in. T equals, now our mean difference is -1.2 minus 0, because the null is that there would be no difference, right? Or it would not be less than. Okay, oops, did not mean to do that. Okay, so, divided by 0.9 0.9499. So our t ends up being, and I just put in negative 1.2 divided by 0.99499. So ends up being negative 1.21 is what I'll round to. That's my t obtained. So now I need to go ahead and go through and calculate my effect size and confidence interval, because we're going to need those when we report our results. Okay? So we now are, oops, sorry about that. Our effect size to calculate that is Cohen's d. It's literally just the mean of the differences divided by the standard deviation of the differences. So it's really the same equation overall. So we end up with negative 1.2 divided by 2.2249. Okay? 1.2 divided by 2.2249. So we end up with 0.54 is our effect size. So now we have our effect size for our related measures t-test. And then the next thing we're going to need to do is our confidence interval. So our confidence interval is a 95% confidence interval. So we need to be really careful with that because of the fact that we want to make sure that we're using a to-tell critical value for that confidence interval. So I'm going to erase some of this information that we don't need right now. I'm just going to keep what we do have, or what we need primarily. So we need our t obtained, and we're going to need our Cohen's d eventually. So I'm going to put d here so that we know that's what that is. But we need to look up a critical value for a to-tell test, because our confidence interval, if you recall, is the mean of the differences plus or minus t crit for a to-tell, and now it's the estimated standard error that we need. And so, and I probably should have kept the estimated standard error written down, so I'm going to write that down really quick so that we have it. Bear with me. So our estimated standard error of the difference is 0.99, I think that's what it was. Let's see, 1, 2, 3, 4, 5, yeah. 50. Okay. So then we're going to need a t-crit for a to-tell test. So what I'm going to do is go back up at alpha 0.05 with degrees of freedom of 4. And now I'm going to look in to-tells. And that would be 2.776. So this here is actually 2.776 rather than the original critical value, which was 2.132, negative 2.132, because we need to have it as a to-tell test. So we're going to take that and multiply it by the 0.9950, and we are going to add, and we're going to subtract that to the negative 1.2. Okay? So the first thing I usually do, bear with me 1 second, I'm going to see if I can, oops. See if I cannot take this. Yep, that's not what I wanted to do. Here's this. Let's see if I can move this. Maybe not. Oh, no. This here. No. Okay. That's not what I wanted to do at all. Nope. Okay, this is clearly a work in progress here, trying to figure this out. But I knew somehow we could take, that's how. Ooh. And I can move it. I knew I could do it. Okay, so we're going to take that and move it. And then that way I can erase this and get it out of the way. I knew I'd be able to do that somehow. Thank you for dealing with my technical issues. So the reason why I did that is because I wanted to show you that, I can erase this, is what I usually do is multiply the critical value times the estimated standard error. So 2.776 times 0.9950 is 2.76, but I'm going to use 2.76. Plus and minus, remember that sample mean difference, which is negative 1.2. So now once I get that, I'll have my upper and my lower boundaries. So I put in negative 1.2, and I'm going to do the bottom boundary first, minus 2.76 equals, and that is negative 3.96, comma. Now I'm going to do the upper boundary, negative 1.2 plus 2.76, and that is positive 1.56. So now I have my lower boundary and my upper boundary, my test statistic, and my effect size, Cohen's d. So now how do we find out whether this is significant or not? That's really kind of the question. So is what I'm going to do is, oops, that's not what I wanted to do at all. I need to go here. Possibly. Not what I wanted. Okay, let's see if I can't get out of that now. There. Okay, sorry about that. So what I want to do is I'm going to take this, not that, just this. No, that's not going to do it. See, I still can't seem to figure out how to work that, but we're gonna deal with it anyways. Okay, so the 1.21, I'm going to take the negative 1.21 and compare to my original distribution. So remember negative 1.21, we're going to negative 1.21, okay, and we're going to go ahead and write down some of this information, and we're going to look at this. So if you recall, our original hypothesis is that we believe students' energy levels are lower after eating lunch. So they're actually not, right? So here's our negative 1.21, okay? That was 0.54. And it's actually a negative, but I usually just drop that negative. Our lower boundary is negative 3.96. Let's go back again, is 1.56. So here's where I'm looking at those. We're going to write our results, and it's going to be energy levels of students were not significantly lower after lunch as T, and we're going to put our degrees of freedom. Remember, our degrees of freedom is the 5 minus 1, so 4 equals, and that's our T obtained. If we look back, negative 1.21. P is larger than 0.05. Remember, it's 0.05. 2 tel. Oops, I'm sorry. It's not 2 tel, remember? It's 1 tel. So 1 tel with, and we have our, we're going to put our Cohen's D, and we'll go back really at 0.54, and a 95%, because we're at 0.05, so remember that's 5%, the rest is in the middle, and we're going to put our lower and our upper boundary in. So negative 3.96, comma, and our positive. And then I'm going to close my bracket and put a period. So there we have our APA result. Okay, and that's key to have it in APA format. So we have our basically our dependent variable. So that is our energy levels. And we have our independent variable or quasi-independent variable. So that after lunch, that implies that there was a before, even though we didn't state both before and after. That's really what we're looking at is the time. We have our degrees of freedom for our T obtained. P is greater than 0.05 because, again, this T obtained fell in the larger portion of that distribution. We've stated whether it's 1 or 2 tel, our Cohen's D, which is our effect size, and our confidence intervals. The lower first, then the upper confidence interval. This is the APA format, and once again, I'll remind you, this is extremely important for being sure that you get full points, is that you are able to make your statement, not only make the correct decision, but state it in the correct format, which is a very precise order. It's like a language. So that wraps up our related measures t-test. I will upload this on Canvas, and please don't hesitate to ask questions if you need.